Namaste. I, JVN Narendra Kumar Chahar, Assistant Professor in Department of Computer Science and Engineering in Jyoti Vidyapeeth Women's University, Jaipur. Today we are going to discuss about compiler design. So when we talk about a program which is about to execute, or we run any program, so that goes from some sort of steps, like we write a program in a high level language, just like we can write any program in 0 and 1s. So we write in a language which contains any letters or any digits. So a high level program first is pre-processed by a preprocessor. After that it will be converted into a pure high level language. Just like we write any C program, just like we include something, or after that we write a program. So the preprocessor removes all the tags or inclusions of a program. The pure high level language has no hash programs in it. After that, a pure high level language is compiled by a compiler, that is converted to assembly language. So assembly language further passed by assembler, which is converted to a machine code. So this machine code is relocatable. Just like this machine code, maybe we write a program, just like a program can be directly executed, or we can create an object file of that. After that we can execute the program. So there is a loader which takes the machine code, that is relocatable. After that is create a absolute code. So the absolute code which is understood by the machine. So this whole process goes for a program. So we are going to discuss about compiler here. So there are some steps in compiler. So when we compile a program, there a complete program is written there. So first of all, it divides into tokens. After that, it generates a tree. It is verified or not. After that, a intermediate code generation, code optimization. So when we talk about the high level language, which is a pure high level language, is as an input in a compiler. So first of all, a lexical analyzer is there that creates a stream of tokens. After that, a syntax analyzer that creates a parse tree. After that, a semantic analyzer that verifies the parse tree generated by the syntax analyzer. So we call a parser to a syntax analyzer most of the times. So when a parse tree is semantically verified by semantic analyzer, after that it goes to intermediate code generation. So intermediate code generation generates some addressing modes. There's 3 address code is used here. Just like I have to add A and B, so I will write something like T1 is equal to A plus B. So there are 3 places of address. So this is called as 3 address code. After that, the code is optimized for a best solution. Then target code generated, and this is assembly. Just like we can see here, a compiler takes pure high level language as an input. After that, it generates assembly language. So for these steps, we can take an example. So here all the steps are connected to an error handler. There may be an error at any cell, so an error handler is there, and a symbol table always there that manages which process is going to be executed first. So we take a simple example here for all the steps. Just like I have x is equal to a plus b multiplied by c. So there are 4 variables there and 3 operators. So this is input for our program. This is first tokenized by lexical analyzer. So when lexical analyzer, these will be converted into id is equal to id plus id multiplied by id. So we have identifier here. After that we have operators. So here are 4 identifiers and 3 operators, and then a parse tree is generated. Just like we can see, a parse tree is just a simple tree, like here is id, this is plus id, id, but this is not as simple as that, but now this is a parse tree without any grammar. So basically this is defined by a grammar. After that it is semantically verified that it is valid or not. Just like associative rules, we have to calculate b and c first. So here x is equal to a, b and c. So b and c will be multiplied first. After that a will be added to that. After that, after semantically verified, it goes to our intermediate code generation. So where 3 address code is generated, so we simply can take a t1 is equal to b multiplied by c, and t2 is equal to t1 plus a, and after that x, we have to move the t2 in x. So this code is generated. After that the code optimization is done. So we are using two registers here. So instead of two registers, we simply can use one register to directly add this. Just like I have t1, this is b multiplied by c, and I simply take x, which can a plus t1. So it is calculated in just 2 steps. So after that this will be disposed to assembly language. Just like we what we have, multiply t1 bc and add x a t1. So the result of b and c will be stored in t1 first. After that a and t1 will be stored in x. So this is the whole process of a compiler. Thank you.